All right, welcome. Today we are diving into a force that fills our entire solar system. It's a constant supersonic gale, but it's completely invisible. Get ready, because we're going to unmask the solar wind. Our star isn't just some quiet ball of light hanging in the sky. Nope, it's actively breathing. It's sending out this constant supersonic wind that washes over everything. Earth, Mars, Jupiter, all the way to the very edge of our solar system. So the big question is, what is this stuff, and how in the world does it pull off this great escape?
To figure that out, we have to start right at the source. And that means heading to the sun's incredibly hot, fiery outer atmosphere, a place called the corona.
Okay, first things first, let's get a quick definition down. The solar wind isn't like the wind you feel on Earth. Not at all. It's actually a plasma. That's a fourth state of matter where gas gets so incredibly hot that electrons are literally ripped away from their atoms. What you're left with is this sea of charged particles, and that is what's constantly streaming away from the sun.
But wait a minute, that leads to a huge paradox, right? The sun's gravity is immense, over 27 times stronger than Earth's. It holds entire planets in orbit millions of miles away. So how on Earth does a stream of tiny particles manage to just break free? Well, the secret ingredient here is just pure, mind-boggling heat. The sun's corona is, weirdly, millions of degrees hotter than the surface below it, and at those insane temperatures, the plasma particles are just moving so frantically, so violently, that the outward push from their own heat simply overpowers the sun's gravity. They are literally boiled off into space.
But it's not like the plasma is just leaking out from everywhere at once. Oh no, the sun's powerful magnetic field acts like a gatekeeper. You see, a lot of the magnetic field lines loop right back down to the sun, trapping the plasma. But in these darker areas, called coronal holes, the field lines stretch way out into deep space. These are the open lines, and they're basically superhighways for the solar wind to just blast on out.
And just like any good highway system, this one has its fast lanes and its slow lanes. Turns out, not all solar wind is created equal.
We basically see two main types. You've got the fast wind, which rockets out of those dark coronal holes we just saw. It travels at a blistering 800 kilometers per second. Get this, that's almost 2 million miles an hour. And then you have the slow wind, and I say slow in quotes because it's still moving at a crazy 400 kilometers per second. This stuff tends to come from the brighter, loopy structures you see near the sun's equator. And look, this isn't just some theory we cooked up, it's real. When our spacecrafts out there actually measure the wind, this is what the data looks like. You can clearly see two separate groups of particles. There's a big clump hanging out around the 400 kilometer per second mark, and then there's that other group that makes up the high-speed tail. This is the smoking gun, the proof for the fast and slow winds.
Okay, so we've got this wind escaping at different speeds, but what kind of pattern does it make as it travels all the way across the solar system?
To get that, you first have to know that the solar wind carries a little piece of the sun with it, its magnetic field. As that plasma flows out, it drags the sun's magnetic field right along for the ride. And that creates what scientists call the interplanetary magnetic field, or the IMF for short.
Right, but here's the twist. The sun itself is spinning, right? It rotates about once every 27 days. So while the wind is shooting straight out from the sun, the source of that wind is constantly rotating underneath it. And the result? Well, you can see it right here. The magnetic field gets twisted into this gorgeous, giant, elegant spiral. It's known as the Parker spiral. Honestly, the best way to think about this, and it's an analogy scientists use all the time, is a rotating garden sprinkler. Think about it. The water is always shooting in a straight line away from the nozzle, but because the sprinkler head itself is turning, the overall pattern the water makes on your lawn is a perfect spiral. The solar wind works exactly the same way.
Okay, so what happens when a fast stream on this spiral highway starts catching up to a slow stream that's right in front of it? Well, you get weather, but we're talking space weather.
And you can see exactly what happens right here. A stream of fast wind, fired out from one of those coronal holes, travels along the spiral. But ahead of it is a slower stream. The fast wind inevitably catches up, and bam, it just slams into the back of the slow wind. It can't just pass through it, so it creates this massive pileup, a compression zone. It's literally a cosmic traffic jam.
This cosmic pileup has a name, of course. It's called a stream interaction region, or an SIR, and these are enormous structures. The waves and turbulence they kick up can have some major effects back here on Earth. They can mess with our satellites and power grids, and they're also responsible for creating some of the most beautiful auroras.
And again, we can actually see this happening. We have the data. This is what that traffic jam looks like when a spacecraft flies right through one. You see the wind speeds suddenly jump up. And right at that boundary, look at that. You get these huge spikes in the density of the particles and in the pressure. That's it. That's the compression zone, caught in the act.
So let's zoom out for a second. This wind escapes the sun, it spirals across the solar system, and even creates its own weather fronts. But what's the endgame? What is the ultimate result of this constant, unending outflow?
It creates this, the heliosphere. All of that outward-flowing solar wind inflates this gigantic magnetic bubble in space. And this bubble is so powerful that it pushes back against all the gas and dust from the wider galaxy, what we call the interstellar medium. It creates a safe pocket, a protective cocoon for our entire solar system to travel in.
I mean, just think about what this really means for a second. It means that Earth, and every other planet, is technically flying through the outermost layers of the sun's atmosphere. We live inside our star. So you see, the solar wind isn't just some far-off curiosity, it literally carves out our home in the cosmos. It's the shield that protects us from harsh galactic radiation. It really makes you wonder, right? As we get better at studying the winds blowing from other stars, what will they tell us about the potential for life on the worlds that they protect?